My name is Hiroki Kato from JAXA. The title of our presentation is RACS2, the ROS2 and cFS system launched. So motivation. So we have more explorations and good activities in space, and we have space robotics. So it's going to be more, we need more robots and intelligence there. So, here's here's good example which I'm working on right now. This is called MMX, Martian Moon Exploration. So that's we JAXA had Hayabusa 2, which went to the Ryugu and then got sample returned back to the Earth. And the next target to the our target would be Phobos. It's going to be launched in 2024. So I'm co-leading the building a robotic system of the sampling system. So I'm from ground robotics systems. So I wish I could use ROS, but no, everything's in C and C++. All right. So yeah, I love it too. But I love ROS. But anyways, so that's what we do. It's more single robot. Just we still can bear with it. For the Hayabusa 2, we had only touch and go, so it's just not much intelligence. It's just mechanical thing going like that. But this time we can actually land and get where to search for the sample and then get it from somewhere which is a good place. So it has some intelligence, but we can't use lots of stuff from ground robotics. So, but now we have another picture here. This is astronaut, and this is from Apollo mission, and he's conducting some scientific mission. So he did it, and then, but he's now he's more fancier lunar or hotel bases, which is built by probably robots, and then that's bigger. But when it gets larger than that, what happened is it just just only this guy can't do that. Just do we carry thousands of them? No. So we need robot, and then we need more sophisticated software system and the robotic system. So theoretical challenge. So robotics missions stay not reusable, non-scalable, therefore expensive, because software needs to be designed, manufactured, and tested for each mission, which I am doing right now in MMX. So hypothesis, we have space robotics missions would be more scalable and therefore cheaper if standard platform like ROS2 and the ground robots is applied to space missions. And robotics using ROS join to the space robotics. So so motivation, good about ROS. We probably, many of us know what ROS and ROS2 is. So it's this is from a good, nice ROS2 or ROS website, and it's gluing together and get lots of tools and then lots of capabilities, and everybody's using ROS, so it has ecosystem. So if I can use it, somebody in the world can use it. So which is good thing. So that means it reduces cost and the scalability goes up. So that's a motivation here. Good about ROS, but why not in ROS in space? So where it's technical reasons, not for tolerant and the safety functions. So so emergency detections and application monitoring, blah blah blah. And also we kind of think of emotional reason. That's what I would think of. You know, it's not flight demonstrated, and then it's the only example of ROS2 space robotics is, you know, just it's in ISS robotics. So we had Robonaut 2 and Astro Beast, and then we had Int4. But you know, it's but once those robots get just some failure, but you know, crews in ISS can help them out, so that's good news. But it's just, you know, we need more forward on that. So our proposal is the ROS and cFS system. So we call it RACS. It's actually it allows users, including ground roboticists, to easily develop new applications for space robotics. So it's available on GitHub. So we actually have created built ROS1, RACS1, which utilizes ROS1 code. But as you probably know, ROS1 can run in Linux. So we needed to like a port and translate, and you know, it was lots of work. But and we actually developed in previously, and it's also in this repository. And we did some presentation in Flight Software Workshop, and now we are launching RACS2. That's ROS2 support, aiming to use ROS for critical space systems like cFS does. So and we are planning to flight evaluation on interval 2 at ISS this year. So RACS2 overview, it runs on non-Linux OS, including embedded system. So it's compatible with processors for space. That's good news. So now it's built on the top of the DDS and RTPS as its middleware. So that's it's more closer than ROS1 for space users. That's good news. So now, what is RACS2? So it in one word, it connects between ROS2 and cFS. So it can run non-Linux processors, so possible to coexist with cFS. So you know, we are aiming to use ROS for critical space system like cFS does. So we prepared two plus tools. One is the ROS2 CFE bridge, which literally bridges between ROS and the cFS in application layer. And tool number 2, RACS2 extended DDS. So we are digging into the connection layer and then using ROS2 and the cFS via DDS layer. So it's more deep into the communication. So for tool number 2 plus would be space qualified QoS. It's not implemented yet. And I have to convince that we have released this one, but we had some fatal problem. So as of today, it's not on GitHub. It's gonna be there in a few weeks, I promise. And it's gonna be yeah. So that's, I'm saying the same thing. Let me explain a little bit about architecture. So I said tool 1 ROS2 CFE bridge is bridging in application layer between CFE and ROS2. So it's running in application layer. So it is pretty straightforward. Just, you know, we can coexist CFE, which is, you know, we have lots of reusable CFE modules, and then we could add ROS2 part of it, and then we bridge it. So that's what it does. And so this is tool 2, RACS2 extended DDS. So it's communicating ROS2 and the cFS via DDS layer, enabling to control quality of service QoS of entire software system. So it's somewhat speeding up the communication, I believe. So it's it's not well, if it wasn't here, it could communicate via cFS and those two applications. So once we get this communication layer, we will trying to tune it up, but we haven't get it yet. But it's just we are kind of assuming it's going to be happen. So if we need some hard time frame work for the every time segment, and then we just try to control this kind of stuff. But we'll be there pretty soon. So we have space ROS, and we have RACS. So what's the difference? So it's, as you can look at this, so while we have space ROS, just single ROS2 architecture, we have CF, for RACS2, we have cFS as well as ROS2. So why do we do that? One good news is this portion, RACS2 portion, software is pretty small. So it's simpler to maintain and then, build. While space ROS would be pretty big, it's entire system, right? So it's going to be well. So if I would use ROS in space robotics, I would want to use space ROS very much. But the problem is, well, it's not there yet. And it's, as we had presentation, it's not just a matter of segmenting and then cut chopping software, piece of software, and the modular thing, usable, boom, boom, boom. No, it's going to work. It's all matter of the discussion of architecture. So so space ROS, it could be it's brand new architecture. It may take some time, so to jump in, it's kind of challenging for lots of people to jump in from the first place. Maybe not later, right? But so for this could be a good transition part. So cFS is pretty good, and it's we have robotic part, and then we have good solid bus part, so it can be coexisting together. That's what I would believe. Well, so I spoke out pretty much everything. That's the pros and cons of the RACS2 and the space ROS. So code volume of RACS2 alone is much smaller than space ROS. So that's the thing. And also, satellite bus systems of the cFS plus robotics function part of ROS2 is, pretty feasible, I believe. So, some font is crazy. So use of space qualified ROS and cFS does not guarantee space qualified software. Yeah, that's everybody knows in this room. So but so we have to think about how to put more robotic software to the space, and we have to consider the architectures and then of the entire software. It's not only robotic part alone, right? So we have to think about it. Okay. So we are planning to evaluate RACS2 in ISS, which we gonna launch this big of the robot to the ISS. It flies and then searching and around people. Okay, summary. Developed the ROS and the cFS systems, so we call it RACS2. And yeah, it allows users, including ground roboticists, to easily develop new applications for space robots. So we are implementing RACS2, which connects between cFS and the ROS2. And we have two tools, two plus tools. I briefly explained. And so coexistence of cFS and the ROS2, RACS2, and ROS2 standalone is, controversial, I believe. We still need to investigate guidelines for safety and reliability and usability and maintainability in order to make more solid flight software, and it's available on GitHub. And so this second part, it's going to be available in a few weeks, I promise. Okay, that's pretty much all about my presentation. Thank you.